Okay, we're going to have a look at quadratic inequalities. I don't think you'll find these hard at all. Basically, if you look here, you've got x squared plus 7x plus 10, which is quadratic. An inequality has got one of these signs, less than or greater than signs. First thing you do is you find the critical values by solving the quadratic equation, and you set it equal to 0. So if I just run through this with example, so if you see here I've got the quadratic, just set it equal to 0 and solve. You can either use the formula or factorise. That one factorises quite nicely. What multiplies to give 10 and adds to give 7. So 5 and 2. You put each bracket equal to 0 and you solve. Now these are what we call the critical values. So that's your first step. Then it says sketch out the graph with the critical values being the intersection on the x-axis. So what that means, so sketch out a wee graph. Now, it's only a wee rough graph. So -2, -5. This is where the graph crosses the x-axis. And I've said if it's a positive x squared, it's a happy face. If it's a negative x squared, it's a sad face. Now mine's a positive x squared, so you just draw a happy face in there. Now, third bit, find the region. This is under, so we're under the x-axis, and this is above, so we're above the x-axis. So if you look at yours, you're under the x-axis. So here's the x-axis here. I'm under it between -5 and 2. So everything between -5 and -2 is under the x-axis. So we say -5 is less than, because I've got wee equals in there, make sure it's equals down here. And that's why I say I'm under the axis between those two values. And that is it. Go to example 2. So set it equal to 0 to find the critical values. Factorise, pull out an x, set each bit equal to 0. So x plus 7 equals 0, x equals -7. Sketch out a wee graph. So it crosses at 0 and -7. It's a positive x squared, so it's a happy face. This time I want above 0. So here's the x-axis, I want above it. Now can you see everything to the left is going to be above -7. So any x to the left. So I sort of remember it as this arrow's pointing down and I'm pointing this way. And everything to the right of 0. So everything this direction of 0. It didn't have a wee equals, so we don't put a wee equals in there either. And the last example. I'm going to factorise this. So that's your AC method. So AC is 2 times -3, which is -6. What multiplies to give 6? 6 and 1, 3 and 2. It's a -6, different signs. The magic number is 5. It's going to be the first one. So 2x squared plus 6x minus 1x, take away 3, equals 0. Do the first two, 2x, x plus 3. Pull out the minus of the next two. Now pull out the bracket, x plus 3, 2x minus 1. Put each bracket equal to 0 as normal, and solve. So putting this one equal to 0, so 2x equals 1, x equals a half. Draw out your wee graph showing the critical values. So x is a half. It does not have to be neat at all. X is -3. It's a positive x squared graph, so it's a happy one. I want beneath the axis, so beneath the pen, that is between -3 and 2.5. And you always point the arrows down the way whenever you're between two numbers. There's no equals there, so there's no equals in the answers. So if you could do exercise 5A, and it's the odd numbers, I will put those up online so you can see it. And I have all my answers. I'll put those up as well.